Hello, everybody. Thanks for coming to CodeSec Days and checking out this conversation. Very excited today because we're going to talk about taming the machine identity mess. I'm Dwayne McDaniel, developer advocate here at GitGuardian, and I have two very special guests. And as a way of introduction, I actually want to frame how we think of the developer experience when we think of cybersecurity and this problem of machine identities. Here at GitGuardian, we want developers to work in ways that make them more productive, put those guardrails in place to help them do their work. So, Uzi, Evan, I'm going to ask you to introduce yourself and just give us a little perspective on your role and how you see that developer experience fitting into this cybersecurity puzzle.
Okay. So, hi everyone. My name is Uzi Elon. I'm the VP DevSecOps at CyberArk. I run the go-to-market to our secret management solution and focus right now on the two SaaS solutions that we have. And the questions that you ask me about, or maybe I'll give you the high-level overview about the way I see the developers, the DevOps team involved in the security, is that today security it's not just part of the security teams. We're talking about the developers are part of the security. And today, when they write the code, they need to think about security and make sure that they are doing the right thing and make sure that everything that they're doing is secured. There is a lot of challenges there, and I believe that we are going to talk about it later on in deep, but I will stop here. Developers must take control of the security. This is part of the role today.
Thanks very much.
Hi, everyone. My name is Evan Litwack. I'm the Senior Director of DevOps Solution Strategy for CyberArk. So, like Uzi, I manage the strategy of our DevSecOps group. And when I think about development and its responsibility from a security perspective, I think the responsibility around security is writing good code and making sure that you don't have the vulnerabilities you'll in your code. Like, for example, you're making sure that you've left out all the old buffer overflows or anything like that, and as well as making sure that you don't have any hard-coded credentials in your code as well.
Something we firmly believe in here at Get Guardian as well. Well, let's just dive into it. We're here to talk about, well, secrets and secret management and keeping those secrets out of your code. But specifically, we're here to talk about machine identities. So let's just kick off the conversation with what's the big difference between securing human identities and machine identities in the world of DevOps?
Sure. So when I look at what the difference between a human identity and a machine identity, the funny part is I actually see no difference. There's one little catch there at the end, but if you think about it, as a human, you get up every day, you have your user ID, you log into your computer, you log into whatever system that you have to give you access to all the company resources, whether it's an LDAP or a cloud identity system, so on and so forth. And then you access those resources to accomplish your task. An application actually functions identically if you think about it. The application starts up, it has a credential that it uses to be able to access resources, and then it accomplishes its business function. The one catch is that our brains, as far as we know, are secure storage. Applications don't have that. So anything that it would use that would be potentially sensitive resides on some form of public storage and therefore needs to be secured. So when we start to look at machine identity, it's being able to authenticate an application not off something the application knows, but more off something the application is. Because if we have a credential in it, then we wind up with a Russian doll problem of I need a credential to grab a credential, I need a credential to grab a credential, and I just have an infinite recursion of back and forth on grabbing creds. Whereas if I authenticate off something the application is, I stop there and it's not something you can change without changing the application. Much like, hey, if I have an iris scan, I can't change my eye unless I change my eyeball.
And I just want to add one more thing. So I agree with Evan. It's semi-human, but the authentications ways are different. But I want to add one more aspect regarding the secret management applications. If we are, as a human, can wait 5 seconds to log in, and in some cases when you log into some system it can be more than that, application can't. So regarding the application, the secret management application, when we are dealing with application, time and performance is important. So we cannot wait. We need to deliver the secret very, very fast. So it's a different way to authenticate than human. Application has no fingerprint, but we also need to think about performance, how deliver the secret as fast as possible in order to let the application continue to run.
Here at the beginning, I just want to dive a little bit further into definition because there is another term floating around out there related to all of this, and that is workload. How does workload differ, or does it differ from machine identity when we're talking about secrets?
I personally don't think it differs. I think it's roughly the same, but you could kind of make a separation depending on how the application is set up. Now that I think about it a little bit more, if you look at a modern application, I have a machine identity, but I also have an application that could be broken up into different services. And if I'm looking at the different services, each service may be accomplishing a different task that has a different credential. Therefore, I would want to authenticate each workload separately. And I'd be looking at it from a workload identity perspective, more so than just a application identity or a full machine identity, if you will.
And adding for that, so we're talking about the new and modern application. So if in the past we had one application that's been executed on well-known server with well-known ideas, there's been a strong correlation between machine and workloads. In today's world, everything is so dynamic. I can spin up and down machines, and the ID of the machines is not part of the identity of the workload. And this is why workload in all the Kubernetes environment become very important.
Thank you very much. That helps us set the stage for the rest of this conversation. So we have a basic lexicon now, machine identity, workload identity, and that's really the problems that we're talking about. We at GitGuardian have been talking about that problem in context of secret sprawl for a while now, and now it's time and place to go into all of the fine details of our reporting on that. People can download that at will. But CyberArk actually has a very similar concept out there that we've been seeing pop up in conversations, people we've been talking to, this idea of vault sprawl. What exactly do y'all mean by that?
So if you think about it, right, I'll actually go back in time.
Okay.
So if you think about the old days of doing things, right, it was most of the time if you had an application, vaulting the credentials wasn't an operational concern. It was really just a security concern, right? Because the application, as Uzi said, ran on a well-known static server. You could basically just encrypt it in a file, and everything kind of was all set to go. I think with modern applications, you can't really do that because it's things that are ephemeral. They only exist for a few seconds. You don't want the credential as something as obvious as hanging out in a manifest that you would need to run. So the need to vault credentials became operational, not just security based. And once that happened, it became, okay, well, I understand I have this problem. Where can I put them? So you have CyberArk solution for this. You have AWS has Secrets Manager. Azure has Key Vault. Different products have their own ways of storing and vaulting credentials. I think like Jenkins has a credential plugin. So with that being said, you start to develop all these different places to store credentials effectively based on personal preference as a developer. And then you get some sprawl on that because now I have some creds in AWS SM. If I'm multi-cloud, some in Azure Key Vault. If I'm, some may decide I just want to use Kubernetes secrets. And each developer is now storing those credentials their own way with their own information. So what winds up happening is that you get a collection of different vaults, even multiple of the same that exist in the organization, all using different standards to effectively store and manage those credentials, which kind of creates a big, ugly, hairy mess that you really don't know what's going on. And it's something we see quite often with our customers.
And Evan mentioned the more of the same application. Just want to share with you more of the same vault. I want to share with you a few real life customer environments that I worked with. So first of all, when we are talking about microservices today, every application break into a very small microservice, and every microservice, and this is the best practice from the cloud vendors, that every microservice will manage its secret in its own vault. So suddenly we have vaults per microservice, and not only that. Now we have vault per environment. So vault per microservice, vault per environment. So I have a customer that already have 5,000 different accounts, which means that they have at least 5,000 vaults. So it's not just the few votes. We're talking about big number of votes, and the biggest challenge there when we have votes everywhere is how can I governance that? How can I make sure that we have the right audit for that? So the management of the operational activity, the security operational activities that need to be taken on the votes become very, very complicated.
Yeah, look at Microsoft's best practice for AKV, actually. If you
Yeah.
look, Microsoft basically says you use a key vault for each application, use a key vault for each environment. So the number of key vaults at that point is multiplicative. When you start to kind of understand what's going on, hey, at some point it needs to be centrally managed. I mean, one of the things that we see quite a bit, which is interesting, is you start looking at the cloud vaults, and a lot of times you literally just have a password value. You don't know what it's to. You have no idea what it's for. There's literally just a password. And now the problem is the way that I equate it, going back to kind of like the late 90s, early 2000s, it's like people using their own ID for running services, and then they decide to leave and get a new job, and you deprovision the account, and all of a sudden everything breaks and you don't know why. So you have this key vault, or this vault basically, that just has a password in it. Well, now I can't delete it because I don't know what that's to. And if I decide to delete it or change it, I'm going to break something, and that's bad. So understanding and having well-defined process and how this needs to be, what kind of information you need to put in there, and how that information needs to be stored becomes even more critical for exactly that case that I just mentioned. What happens a few years from now?
And interesting, based on what you just said, that I had a customer that told me there are the best practices and there is the reality. And when we talked about it, and I want to raise another topic, is why do we have this challenge? So we talked about the developers. They want to have their own key vault. They own the key vault. They would like to have a separated uh, project and segregated secrets. That all makes a lot of sense. From the other hands, we have the security team. They need to make sure that they have the governance, the control. So this mix that said, okay, the best practice, or I need to have a lot of secrets and I need to manage it, and the developers own those secrets, is taking the industry into one side, but then the securities are looking for more central solution, that looking for more governance and audit, take the world into a different area. And this is the clash. And this is why we are in CyberArk try to build a bridge between these groups and make sure that the developers will be able to continue to work with their segregation environment, but we need to give some kind of central solution for the security team to control all these small vaults. So that's what we're trying to do. We're trying to build something that will give value for both of them, because if security team will try to force the developers to change the processes, it will not going to work. And if security and developers will continue to work only the way that they work, they are going to add some vulnerability and some risk to their organizations.
So before we dive in a little bit more on what should go into a solution and how we go about fixing this, I do want to dig a little bit deeper into this vault sprawl issue. There have been a few reports of people storing credentials in what seemed like the best practice at the time way that turned out to, well, cause issues in the long run. So, what are some security implications?
We introduced our solution to the security team, and the first questions that I heard after that is, so which secret should I manage? Can you help me to find those secrets? I don't know what I'm looking for. So these questions return over and over again. So the problem is that we know what we need to do, but we don't know what we are looking for. So this scan capability, the ability to identify, discover, and find all the secret in all the different storage and repositories is a key. I can tell you that we have an integration together, and we ran some scanning using Git Guardian to CyberArk. We have some discovery capability in our tool to find some secret um, in the cloud. And something that always amazed me is how many secrets that found by the tools never been used. So it's not just that someone did something or changed something and then he keep using it. Sometimes they just upload a secret to a location and that's it. No one actually used it. No one rotated it. So it increased the risk. And the secret is there, and the secret still can access to a specific resource, and no one know about it, and no one even sometimes no one used about it. I had a customer which created a database and add manually the secret to the database, the DBA root secret to every AWS secret management, in order to make sure that if some DBA will log into the machine, he will be able to access manually for debugging purpose. So we have a secret that mostly never been used, and it's there. So the Vault Sprawl is all about the situations that you lose control on your secrets.
So, let's talk practicality. What should we be putting in vaults, and how should we be leveraging a vault system? So, I always like to think of the magic wand analogy, and you can just poof, this solution's now in place, and everybody is using it effectively. What does that world look like?
So, I want to start somewhere first, though. We've been talking about developer experience here, and from my own personal experience, I think using a vault, as much as we'd all like to use it immediately and just keep doing that,
Mhm.
it may not necessarily be practical, because if you think about it, if I have to write code, right, I need to get what I'm building working first.
Yeah,
And what I don't want to do is add any complexity to that. So in the lower environments, you tend to see the hard coded passwords because, well, quite frankly, I'm trying to validate my code works. I don't want to add another layer of something that could mess it up. Sometimes, mistakes are made and the credential still lives there when you commit it to a higher environment. You comment it out and you forget to delete it. These things happen all the time. And I think in a lot of cases, one thing to talk about is that, and I'll say a huge advantage to Get Guardian is that it's out there to be able to catch those situations. It's like an emergency parachute for when you make mistakes, to make sure those mistakes don't get any bigger than just an oops. And to me, that's honestly one of the best forms of security, which is just kind of, hey, let me catch something before it becomes a problem. Ideally, yes, you'd want to be able to do that, but still, when we start to get into the higher environments, yes, absolutely, the credentials need to be vaulted. And I think, even though we just had a conversation about vaults being all over the place, there is a place for it. I think the concern is that they all need to be centrally managed. You all need to be able to follow processes that say that if I'm putting a secret in a vault, I need the following information to go along with that secret so that I know what it is, I know what it's going to, I can effectively manage it. And by manage it, I mean that it is changing on a relatively frequent schedule. I dealt with customers that have told me all the time that they're utilizing dynamic creation of credentials and so on and so forth, and then you find out that dynamic creation translates to once every 6 months or once a year. And that is the antithesis of dynamic. So, we really would prefer them changing every 30, 60, 90 days because that minimizes the footprint of how long that thing is out there. I would also say being able to consolidate those vaults under a single pane of glass. Having all of those vaults in one place is fine, or excuse me, all over the place is fine, as long as I can see what's going on in one place. As long as I'm able to manage the rotation of those credentials in one place, as long as I know who has access to them in one place. Because one of the other problems is somebody leaves, application gets deprovisioned. Do you know everywhere you need to turn it off?
And I
It,
want to add the aspect of the developer side. So yes, the central solution rotation is a key, but let's talk a little bit about these magical tools or the best tools that give value to everyone. So for the developers, it should be almost transparent. They need to make sure that it's easy for them to get the secret. They need to make sure that we don't need to ask them and go back and change their code, because that's something that takes a lot of time. So it needs to be very easy for them to consume the secret. But also, there is a lot of automation processes and automation tools to introduce a new secret. So this tool should allow them to do it in a very natural way. So if they're using a specific automated tool, we need to have the right plugin in order to have the option to introduce a new secret in a very easy way. So ease of use, the ability to connect to their existing processes, and today the existing processes, it's all about automation. That will be a key for the developers and for the CI/CD tool. So security, yes, they need to have the central solution and the rotation. Developers, it's need to be almost transparent to them.
We go practically from here. Now, again, ideal situation, we wave that magic wand, and now every developer does this perfectly every time in every situation. But in reality, that's not the case. We're human beings. Human beings are error prone. That's part of what makes us wonderfully human. So how do we march down this path of getting to better centralized managed secrets, knowing that developers will be developers?
I look at it as a last mile question, actually. I relate secrets management to networking in a way, which is, you have your pipe, but the last mile is the important one, and that's your secrets delivery. Applications generally have a set of how they want to be built. Like some people, if it's an AWS, hey, we're going to use AWS native tools, we'll use AWS Secrets Manager. No problem. Hey, I have an application, we're a Red Hat shop, we're using OpenShift, we want to store things in OpenShift secrets, or we want to use the external secrets operator, or we want to do something along those lines. Again, no problem. When you start looking at it, it is from a velocity perspective and a comfort perspective, as well as a security perspective. Let the secret itself be stored or be managed centrally, but how it is delivered to the application be done in a way that is comfortable or previously done for that application, because not everything is greenfield, and manage that appropriately.
And another aspect for that is, as you mentioned, developers sometimes will commit the code will commit the secret into the code. So that sometimes are going to do some mistakes. Everybody are doing a mistake. So in this case, connect the scan into the CI/CD, the ability to scan every time, and at the moment that they found a mistake, to be able to fix it, automatically or not. That will be the add-ons that are required in order to keep the hygiene of the secret management program. So after building the problem, onboard all the secret, start to have the rotation. You need to remember more secret will be added, and you need to make sure that the new secret will also added to the right location. Of course, adding more automation, help the connector connect to the onboarding best practices and processes will help to reduce these kind of errors. But if errors will happen, and if a secret will be committed into a repository, we will be able to find it and fix it.
So let's talk about that findability as we're wrapping things up here for the end of the conversation. The part of the problem of centrally managing these things is, well, finding everything, an ability to manage it. And you said it earlier, yeah, Git Guardian definitely can help with that. But just finding, getting a giant list or a dashboard full of here's the secrets you know about, that's a step in the right direction. Uh, but how do you see that all coming together? What's the practical, workable solution there? Like we found them, now what do we do?
So I would say you find them, and then it's actually a little bit of sleuthing, because then you have to kind of start determining what information is there, how those credentials are being used, um, where they're being used, and then sometimes you have the information, sometimes you don't, for your brownfield environment. So you kind of have to figure that out. And then for your greenfield environments, you can absolutely put automation in place to make sure that anything that's used, or anything that's created, is automatically created in the way that we need it. And the great part about automation is that and a lot of times it removes that human error from the equation. So in one hand, you're basically no longer creating the same problems you had in the past by automating it, and having everything shifted a little bit further left. But then on the same note, you're also doing your research to help clean up the brownfield that exists from what you've already done.
Yeah. So automation and onboarding, the ability to onboard the secret into a secret management tools, that will be the key. Maybe it can be upload to a staging area and then get approval into the main system, but identify it, automation, and ability to upload it, that will be the key. And of course, mention it to the developers. This is a mistake. This is what we found. Let's make sure that that we onboard it into the secret management solution. But let's also think about how can we reduce this kind of event in the future.
So it all goes back to that wonderful triad of, if we're going to make any improvements, it can't just be new technology we're throwing on top of the stack. It can't just be saying, hey, you as a person are messing up. And it can't just be, hey, here's a new process, learn it or don't. It's got to be that marriage of those three. And that's how we will actually practically make improvements and keep growing.
100%.
Agreed.
Evan, you actually said something in one of our conversations leading up to this, of security tools protect you from yourselves.
Yes. Yeah, it's trying, like you said earlier, we're humans, and the mistakes that we make, make us wonderfully human. And the goal here is that when those mistakes are made, to make them little mistakes as opposed to big mistakes. And being able to have a safety net underneath to catch those mistakes, like being able to use, like, hey, look, I leaked a secret. Oops, no problem. Git Guardian blocked the commit. Great. It's a little oopsie. No problem. Let me go back and change that. As opposed to, wait a second, I just committed a credential to a public repo. Oh my God. Now one problem is really bad, especially if, let's say, it was a production credential, because even if you caught it, you now still have to go out and change it and your app's down. And versus, nope, I blocked it, no problem. All right, cool. Let me go ahead and get that out of there, and it's a few seconds worth of work, and I'm done.
One thing we didn't get to talk about today, just sake of time, we didn't even touch on this idea of defense in depth.
So I would say check our blogs on cyberark.com, and also the various resources we have. We have a lot of information on how to solve the problems that we've discussed, as well as lessons we've learned over the years of doing this. Most people don't know this, but CyberArk has been managing application credentials for over 15 years. So this is not something that's new to us. This has been a problem that's existed for a very long time.
And just remember, these legacy applications that written maybe 10 or 20 years ago are still run in production in some organizations. So we talked a lot about the new tools, the Kubernetes, the cloud, but yet there are also legacy applications. And I can tell you something, the secret in the legacy application takes you to the same resource that the secret in the new application. So you need to protect them as well.
Well, we're in 100% agreement with you on that. Thanks very much for being a part of CodeSec Days 2024, and thanks again for helping us secure our machine identities out in the world.